Hello students, in this video I'll be telling about the chemical properties of metals. This is your lesson number 4 only, that is materials, metals and non-metals. In the previous session we have learnt about the physical properties of metals. There you have learnt that metals have luster, they are malleable, they are ductile, they are good conductors of heat and electricity, they are sonorous, they have high tensile strength also. Okay, and this way they were different from the non-metals based upon certain physical properties. In this video we will start with the chemical properties, that how metals and non-metals differ from each other. They differ in terms of their reaction with oxygen, with water, with acids, then with bases, and also we will study about the displacement reaction also. So first let's start up with reaction with water. All metals generally combine with oxygen to form metal oxide, which is basic in nature. This I'll be telling you in later part of the slides, that whenever a metal reacts with oxygen, it forms metal oxide. Let's take some of the examples. For example, sodium reacting with oxygen at the room temperature only, and it is forming sodium oxide. Here you can see the picture also, and this reaction is the words which are written in English. This is the word reaction. You should also learn to write the chemical equations also. Chemical equation, we just write the symbol of particular metal and non-metal and the product is written there. Here you can see that sodium is Na plus oxygen, that is O2. It is combining to form Na2O. This is sodium oxide. Let's see some more reactions. Magnesium reacts with oxygen, but it needs additional heat. When this additional heat is provided, it is forming magnesium oxide. This is the word reaction. Chemical equation is Mg plus O2. It is giving MgO. Same way, zinc plus oxygen on strong heating. Okay, zinc needs more heat. Then only it will be forming zinc oxide. The chemical equation is Zn plus O2. It is giving ZnO. Okay. Iron also. Iron plus oxygen. Strong heating, it gives ferric oxide. This is basically the rust. When iron is exposed to the atmosphere, the oxygen is coming there along with the moisture. Then it forms Fe2O3. Fe2O3 is the formula for ferric oxide. Now sodium and potassium. As you can see in the very first slide of this reaction, sodium was reacting with oxygen at normal temperature only. Why? Because it is very reactive metal. So as soon as it comes in contact with air, it catches fire. Therefore, these metals are stored in kerosene so that their contact can be prevented with the oxygen. Okay. Now let's come to the activity, that is activity number 2 in your book, which shows to check the basic nature of metal oxides. You have to check whether the oxides which are formed are basic or acidic in nature. It's a very simple activity. What has been done here, the rust that deposits over iron has been taken, and in that we add water. A suspension is formed. Then you have to check that suspension, that rust suspension, with a red litmus paper. The red litmus paper will turn blue. Though the change from red to blue shows that the nature of metal oxides is basic in nature. Remember this thing, nature of metal oxides is basic in nature, because we have to compare this with non-metals also in the later part of the chapter. So this much for today. Tomorrow we will be discussing reaction of metals with water. Thank you so much. Have a great day.